Howdy, it's Papa. We have talked about the taconic orogeny, which was the first big mountain building event that, in the process of putting together the supercontinent Pangaea. And of course, it happened mainly during the Ordovician period, which was about from 500 million years ago to about 450. Now, I want to look at a place in Georgia that has a big hunk of rock that was produced during the taconic mountain building event and then shoved up onto Georgia during the Akkadian orogeny. So let's take a look at the book, and I will show you this piece of big, huge hunk of interesting geology in Georgia. So here we go. Oops, gotta turn her. Okay. Let's see, let's get this fixed. Okay, hopefully you can see this. You can see Georgia. There's a little indentation and everything. And we're looking at the Eastern Blue Ridge province, which is this area here. This is the Brevard Fault Zone that separates the Eastern Blue Ridge from the Inner Piedmont. And this purple spot is what I want to talk about today. And you will notice there's a gray spot in the middle of the purple spot up here. That's a hole where the purple rock has eroded away, exposing this gray rock, which is really this rock that's underneath it. And right in the middle about of that spot is Brasstown Bald, the highest point in Georgia, which is 4,784 feet above sea level. But it's the purple rock that I want to talk about. This purple rock is called, it has several names, but it's called the Persimmon Creek Gneiss. And we know gneiss is a metamorphic version of an igneous rock. Which could be granite, it could be diorite, andesite, or basalt, but that doesn't matter. It's also called the Coweta Pluton. Coweta Pluton. Okay, now geologists say that this particular hunk of rock was formed during the taconic, and let's go back and look and see what happened. If I can find it. Okay, here we go. Here's what happened during taconic. This was the hunk of the mainland. Here's the mainland that rifted off from the mainland during the rifting of Rodinia. Then ocean crust came forward and subducted underneath this hunk, turned this into a volcanic island chain. At the same time, it produced this giant igneous Pluton, the Persimmon Creek Gneiss, also called the Coweta Pluton. In here, between the mainland and the island arc, in these ocean sediments, the same subduction process pushed Dahlonega gold up into those sediments. Okay, and that happened during the taconic orogeny. I think I have this, or the book has this drawn wrong. I think this Pluton actually was emplaced on this side of the island arc, on the east side, the oceanward side of the island arc. So here's what geologists say happened. This all happened during the taconic, but none of this was shoved onto the continent during taconic, as we have learned. During the Akkadian mountain building event, that's when it all got shoved on. The first thing that got shoved on was the Dahlonega terrain, Dahlonega gold belt. Then the island arc sediments of the Eastern Blue Ridge province and its associated ocean sediments like sand and turbidite sediments from the continental slope were pushed on. And then finally, this Coweta Pluton was pushed on top of everything. So it's absolutely on top of everything else. Dahlonega Gold Belt came first. The Eastern Blue Ridge Province on top of that, and then this Pluton, this Coweta Pluton, or Persimmon Creek Gneiss, as it's called, was pushed on later. That's why I think this is drawn wrong, and the Pluton must have been over here since it was pushed on last. Okay, so now if you look at the geologic map of Georgia, you will see that this purple spot, where'd it go? Let's go to it. Coweta Pluton, the Persimmon Creek Gneiss, is composed of amphibolite, several kinds of rocks, amphibolite, biotite gneiss, schist, and the actual Persimmon Creek Gneiss itself. I have a paper, a research paper, that talks about the Persimmon Creek Gneiss itself, and it says this is an unusual Pluton, and it's made up of a variety of rock types, from metabasalt through diorite and into a rock called a felsic rock called Tonalite. And there's a lot of it that is Tonalite rock. I don't know if I'm making myself clear, but the main thing is this whole purple area is composed of several rock types, from mafic rocks to felsic. And one of the main felsic rocks, these were all igneous rocks produced via subduction and shoved up on the land, was Tonalite. Now, what is Tonalite? Let's look at a piece of Tonalite. This is Tonalite. And this was collected I collected this many years ago, maybe 10 years ago, from off of Highway 76 west of Clayton, Georgia. After you follow Highway 76 west and you go past Lake Burton, and once you get past Lake Burton, you'll pass something, a pull-out on the right called the Popcorn Overlook. And you keep on going past that a little ways, and then you get to the place where I collected this rock. So Tonalite, what is it? You can see it's a felsic rock. It has a lot of, what color do you see? White. A lot of white in there. What is that white? That white is feldspar. And for Tonalite, this feldspar is called plagioclase feldspar, which just means feldspar that's rich in sodium and calcium. Maybe richer in sodium than calcium, but no potassium. It's not potassium feldspar. It's sodium/calcium feldspar. 60% of this rock, plus or minus, is this plagioclase feldspar. You can see the gray or clear quartz pieces. Here's one right there under my thumb. And there's a sprinkling of biotite or hornblende in there. Here's another example of it that has more biotite in it and a finer grain crystals. Here's some more of it. Finer crystal sizes, maybe more biotite/hornblende. So there's a lot of that in this Coweta Pluton. This is the Persimmon Creek Gneiss Pluton that is part of the bigger purple Coweta Pluton that covers that big hunk of northeast Georgia, and would be covering over Brasstown Bald, except it was eroded away, exposing Brasstown Bald, which I presume is made up of Western Blue Ridge Dean Formation rocks, which were part of the Rodinia Rift sequence. Okay, so this is the most interesting and unique rock, and the geologists say this is a unique Pluton, and I just take their word for it. What other rocks did I find when I went there? Let's look at them. Okay, we've got, I like these rocks here. Look at all that dark stuff. What is that dark stuff? What is that dark stuff? This is all the same rock, just cracked into 3 pieces. If you take, the question is this dark stuff biotite or is it hornblende? It's probably one of the two. It's probably one of the two. How do you find out? Well, one way you can get close to finding out is take a nickel and try to scratch it. You can scratch it on top and on the side. If it scratches easily, then it's very likely that you're looking at biotite instead of hornblende. Hornblende's a little higher. The nickel will not scratch hornblende, but a nickel will scratch biotite. And I have scratched these rocks. They do scratch. Not super easily, but they do scratch with a nickel. So I'm calling this biotite gneiss. You could also call it biotite / hornblende gneiss. Gneiss just means it's a metamorphic rock. You can see the metamorphic banding in it where the light-colored minerals have kind of lined up a little bit. Okay, so here's another one. Another sample. A little bit finer grain, some lighter material there. It was easily scratched, biotite gneiss. Maybe I would call this biotite gneiss, and I would call this biotite / hornblende gneiss. And here we have a sample here from that same area. Dark, so you know it's mafic. It's got a lot of iron and some magnesium in it. My nickel would not scratch this at all. Not at all. So I'm assuming this black stuff is hornblende. So since this is hornblende, I'm calling this a mafic rock for sure. And I'm going to say that it's metamorphosed, but it probably began its life as either basalt lava. I'm gonna stick with basalt lava. It could even be a piece of ocean crust that was pushed up, because ocean crust was pushed up along with this Coweta Pluton, and that's what the popcorn pull-out site is all about. And we'll talk about that in another video. This biotite gneiss, which is softer and has a little bit less mafic, you could call it an intermediate rock. It's either going to be, it either started out its life as something between diorite Pluton and gabbro Pluton. In other words, diorite being an intermediate reaction rock, and gabbro being an mafic reaction rock. Plutons, these are underground. Or it could also have begun life as basalt or diorite, and it may have experienced exposure to a lot of water, which would cause it to reverse metamorphose, which does happen, and that would have turned it into from say a basalt. It would have from a mafic rock into a more intermediate rock. But the bottom line is, all these dark rocks represent ocean crust, which is made up of basalt, or an intermediate or basalt lava, or an intermediate kind of lava. That is the kind of thing that you get when you have island arcs form. You get a variety of reactions. What I mean by rock reactions, I mean felsic, intermediate, or mafic. You get felsic rocks, igneous rocks, you get intermediate igneous rocks, and you get mafic igneous rocks generated in subduction and island arc situations. And that's what this rock likely represents. So we have the intermediate to mafic kinds of lavas, Pluton / lavas, and then we have the more felsic Persimmon Creek gneiss tonalite magma lava. And what else do we have? Well, over here, can you see how these rocks are shiny in the sun? Shiny tells you schist. That's mica that's shining, and it's been schisted, which means it's been highly metamorphosed. There's quartz in these layers. So you've got quartz, mica, schist. Most of this mica looks like muscovite, because muscovite is kind of silvery, biotite's black. You've got a bunch of this quartz muscovite schist rock. What did it used to be? More than likely it was sediment, sand and mud. And they are mixed together here, so that means that they were not greatly sorted. Usually the sand and the mud get separated because the sand falls out. When you have erosion situations, the sand falls out first and forms the beaches, and then the mud goes out deeper. But we've got them combined here, so that tells me that these were laid down in a hurry. It could have been associated with the melange when one piece of ocean crust gets pushed down underneath a hunk of the continent, a rifted hunk like happened. A bunch of the material is scraped off and swirled around, and so this may be some of that, but it for sure represents sand and mud mixed together in layers, and that gets metamorphosed into schist. Okay. Now the geologic map of Georgia also shows that there should be some meta-graywacke in as part of this Persimmon Creek Gneiss or Coweta Pluton, this whole area. That would be, I have not found that. I didn't find that 10 years ago, and I'm going to go back up there and look at it. I haven't, but that would indicate we're looking at continental slope material that rolled down the continental shelf and then fell down the continental slope and got all mixed up in these turbidite sediments. And I'll be looking for that when I go up to North Georgia, maybe in a month or so. Now, if you want to see a rock that you for sure is Persimmon Creek Gneiss, then if you go to where the Appalachian Trail crosses Neal's Gap, and I don't know the name of the road, but you can easily find that on the map of North Georgia. Right at that point, there's a structure built of stone, and it's the only stone structure that's built in a gap on the Appalachian Trail. I think I've got that right. But anyway, it is made of this Persimmon Creek Gneiss, this stuff. So I'm going to go up there and have a look at it. Basically, they sell stuff. It's an outfitter where you can buy food and camping stuff on your way along the Appalachian Trail. And I was there many years ago when I was hiking the Appalachian Trail. But I don't know if that rock's going to be made of tonalite or if it's going to be made of something more mafic. But I'm going to go out there and check it, and you can go out there and check it too and see what you see. So that's a huge part of what's on the geologic map of Georgia, that big old spot. And while you're up there looking at the Persimmon Creek Gneiss, if you haven't already, go up Brasstown Ball, the highest point in Georgia, and where you can see forever. In the Smokies, okay, Brasstown Ball is 4,784 feet above sea level. Klingman's Dome in the Smokies is 6,643 feet, so it's quite a bit higher, but the 4,784 is high too, and you have some really interesting plants up there like mountain ash and also pin cherry or fire cherry, which has a flaming golden curly bark that's worth seeing, and they have some good interpretive stuff up there too. Okay, well, I hope that makes sense, and I just wanted to say to all my rock buddies, howdy, hello. Hope you guys are doing well. I just want to say how much I appreciate you because you're interested in rocks too. You must be great folks. So have a great day, and I'll be talking to you soon. Pop out.